Alright class, so the next chapter is all about factoring. So section 5.1 is about factoring out the greatest common factor and factoring by grouping. We're going to need to make sure that we are really strong in this skill set as we work towards factoring trinomials. So the process of finding a polynomial whose product equals a given polynomial is called factoring. And we do this because we'll eventually need to solve equations. But right now we're just going to practice taking these expressions and pulling them apart into their factors. So for example, if I had 4x plus 12, I could pull out a factor of 4 because 4 is the greatest common factor of 4x and 12. And that would give me 4 times x plus 3. You can see if I was to redistribute that 4 back out, I would get back to my original polynomial. We call 4 and x plus 3 the factors of 4x plus 12, and we would call 4 times x plus 3 the factored form of 4x plus 12. A polynomial that cannot be factored is called a prime polynomial. So for example, x plus 3 can't be factored any further. And when a polynomial is factored completely, it's only the product of prime polynomials. So here's how we're going to factor a polynomial. So first thing you want to do is we need to determine the greatest common factor of all the terms of the polynomial. You may need to make a factor tree. If so, that's okay. Next, you need to express each term as the product of the greatest common factor and the other factor remaining. And then we use the distributive property to factor out the greatest common factor. So for example, if I had a, b, and ac, I could pull out a factor of a. So we're like undoing the distributive property. So if I have 9z and 18, the greatest common factor is going to be 9, right? We look first at the coefficients and then at the variables to see what they have in common. So I could pull out a factor of 9. 9 times z minus 9 times 2. 9 times z minus 2. And you could see if I was to distribute this back out, I'd get back to my original equation. Let's go ahead and do this again. I've got 56m and 35p. Well, the greatest common factor of 56 and 35 is 7. And the greatest common factor of m and p is just 1. They don't have anything in common. So our greatest common factor is 7. I'm going to take 7 times 8m plus 7 times 5p. And then I can pull out the greatest common factor. This is a typo. Let's move on to our next example. So if I have 9x cubed plus 12x squared, again, the first thing I want to do is look at my coefficients. So what's the greatest common factor of 9 and 12? Well, that's going to be 3. Then I have to say, what's the greatest common factor of x cubed and x squared? So if I have the same variable, the greatest common factor is going to be to the lowest degree. So that would be x squared. So I've got 3x squared. What do I multiply 3x squared by to get to 9x cubed? Well, that's just going to be 3x. What do I multiply 3x squared by to get to 12x squared? That's going to be 4. So we're just pulling out the greatest common factor. Next, I look at problem 2. We have 24, negative 15, and 3. The greatest common factor of 24, 15, and 3 is going to be 3. If I have k to the 9th, k to the 7th, and k to the 4th, we take k to the least degree. That would be k to the 4th. Now I'm going to pull out a factor of k to the 4th. So 3k to the 4th times what would give me 24k to the 9th? Well, that'd be 8k to the 5th. 3k to the 4th times what would give me negative 15k to the 7th? That's negative 5k cubed. And then 3k to the 4th times what would give me 3k to the 4th? That's just going to be 1. And if I distributed this back out, I'd get my original polynomial. Now let's take a look at example 3. This one's a little bit trickier. I have x minus 5 times x plus 6 plus x minus 5 times 2x plus 5. And it may be kind of hard to see what the greatest common factor is in this case. But what if I had a plus b plus a times c. What would be the greatest common factor in this case? Well, it'd be a. We'd pull out a factor of a and we'd get a times b plus c. Let's go ahead and label x minus 5 is a, x plus 6 is b, and 2x plus 5 is c. So a is my greatest common factor. So I have x minus 5 times x plus 6 plus 2x plus 5. And I'm going to go ahead and simplify what's in these parentheses. So I get x minus 5 times 3x plus 11. The last thing is when we are factoring out the greatest common factor, we never want our leading term to be a negative. So we're always going to have to pull out the negative. So I say, okay, what's the greatest common factor of 18, 6, and 15? Well, the greatest common factor of our constants is 3. Next, I look at my a's. I've got a to the fourth, a squared, and a cubed. So the greatest common factor of those would be a squared. Then I look at b. I've got b cubed, b squared, and b. Again, you pick the one with the lowest degree. So I have b. So here's our greatest common factor. But because my leading coefficient is negative, it needs to be negative. So I have negative 3a squared b. Negative 3a squared b times what gives me negative 18 a to the fourth b cubed. And that's going to be 6a squared b squared. Then I say, okay, what do I multiply negative 3a squared b to get 6a squared b squared? Well, that's me negative 2b. And then what do I multiply negative 3a squared b by to have it look like negative 15a cubed b? The answer to that is going to be 5a. So there we have fully factored by pulling out the negative in our leading coefficient. Next, we're going to factor by grouping. So when a polynomial has more than 3 terms, we can sometimes factor by grouping, okay? So what we're going to do is we're going to group terms that have a common monomial factor, right? They'll usually be 2 groups, and sometimes you need to arrange them. You're going to factor out the common monomial factor from each group, and then you factor out the remaining binomial factor if one exists. So let's do an example. If I have ax minus ay plus bx minus by, I'm going to factor by grouping. So I put in my grouping symbols, which are parentheses, and I factor each group differently. So I say, okay, what is the greatest factor of ax and ay? Well, that's going to be a, so I'd be left with a x minus y. I'm going to add that to, okay, what's the greatest factor of bx and by? Well, that's b times x minus y. Now, this is step 3 where I factor out the remaining binomial factor. Oops. Do you see that this and this are equal? So I can pull out that term. So that gives me, I collect my greatest common factors, a plus b times x minus y. Let's do another example. I put in my grouping symbols. The greatest common factor of mp squared and 7pm is m. The greatest common factor of 3p squared and 21 is 3. So I collect my greatest common factors and what they left behind. I can always check my answer by foiling. Foiling is how we multiply 2 binomials, right? It's first, outers, inners, and then last. All right, here we go again. I'm going to put in my grouping symbol. The greatest common factor of 4x cubed and 2x squared is 2x squared. 2x squared times 2x plus 1. The greatest common factor of negative 2x and negative 1, remember we don't like negative leading coefficients, is going to be our negative 1. I get 2 things that look the same. That means I've done this properly and I can factor by grouping. I collect the greatest common factors. and what they left behind, that binomial factor. Last but not least, we put in our grouping symbols. 6ax plus 12bx, the greatest common factor of that's going to be 6x. That leaves me times a plus 2b. The greatest common factor of a and 2b is a positive 1, right? That's the only factor they have in common. I'm still going to pull that factor out. So I have 6x plus 1 times a plus 2b. And it's important for us to take that 1 out. Otherwise, if we were to FOIL this, we wouldn't get the correct answer.